So first of all, thanks for letting me come let me come digitally and talk to you about the PaN Learning e-learning project. I'm going to try and keep this talk brief for a few reasons. The first is it's the last talk of the day, and I know that you all have the conference dinner coming up. The second is that because I received a threat from one of the organizers that they would behead me if I ran over. And thirdly, because I can't actually see anyone in the room, you could all leave without me noticing, and I wouldn't know. So I'm going to try and keep it brief, keep it exciting. And if you do want to leave, Alan, I won't know, so it's fine. So I'm Andrew McCluskey. I work at the ESS, and I'm actually one of the work package leaders for one of the PaN-OSC projects, and specifically this PaN-Training e-learning project. And that's what I'm going to tell you about. Of course, as with all things, and we're all familiar with this idea in software development and neutron science in general and X-ray science, this isn't something we do alone. And I actually only became work package leader of this project at the start of this year. And before that, there's been lots of different people working on it. So I wanted to just acknowledge them, in particular Stella, who was a postdoc at ESS in 2021, who did a lot of the work in order to get the kind of e-learning platform up to date. My second bit is just to say, similar to Graham on Tuesday, or on Monday actually, I speak quite quickly. Worse than Graham, I have a thick accent. So if you find that you can't understand what I'm saying, try and let me know, and I'll try and either slow down, which obviously you don't want because then I might run over, or I'll try and speak a bit clearer. And then I'm happy to take any questions that anyone might have through the Slack, because that's probably the easiest thing rather than hanging about for questions afterwards. So this is my quick outline. So I'm going to cover four things. I'm going to explain why the e-learning platform is important for the facilities that we work at. Then I'm going to give a very brief introduction about PaN-OSC and a slightly less brief introduction about PaN-Training. Then I'm going to show you a demonstration of the e-learning platform. Now, I've been watching the talks this week, and I've seen some demonstrations go a bit awry, so I hope everyone crosses their fingers for me. And then at the end, I've got a bit of a call to arms, because one of the things that's going to drive this e-learning platform into the future is working together across the different facilities and trying to engage in collaboration with this. So we do training at our facilities. That's the kind of short part of this. This is part of our role in operating user programs. I imagine that all of the facilities represented at NoBugs have some form of user training. Now, I've picked some, I picked randomly because they're informed by my previous work and my current work. But I've picked some examples here. So there's a training event at Diamond that took place back in July. This was from 2018, something at JCLS. This is something that happened this month in Sweden, and this is the ICE's Neutron Training course. These are all events, not all of them necessarily programming related, but all events that we use in order to train users to use the facilities that we're working on. And this is a really important aspect of our role as a user facility. But there's problems with this. We organize these schools and workshops where people come to learn about the techniques that our facilities provide or the software that we develop. And often pre-COVID in particular, these take place as in-person events. I put in-person in italics because as a result of COVID, these in-person events are now often Zoom events. But these Zoom events can have the same problem that in-person events have with respect to kind of selectivity. When they're in-person, physically in-person, then we have the problem that we're in classrooms or seminar rooms that can only fit a particular number of people. And when we're on Zoom, we can only obtain enough helpers to cover a certain number of participants. The result of this is that often we just get, say, one student from a given user group coming to these events, and they're meant to be the expert from that training course that takes it back to their user group. And this is a bit unideal because it creates a selective system. And further to that, when we're doing physical events, that also means that it's selective based on location, which isn't the best situation to be in. And further to that, there's even limitations when we use these traditional kind of approaches, because when we're doing, now we're not all guilty of this, I respect, but often these schools are taught using a series of lectures, and the lecturers might have handouts or these kind of similar passive learning methods, and a bunch of studies have shown that this isn't actually the best way to teach. And we should actually create active learning where we provide things that students work through and read through before the lecture, and then when they come to the lecture, we can focus on answering questions and dealing with problem-solving examples so that they can really consolidate the knowledge they've been introduced to. Furthermore, from the kind of point of view of us programmer-y people, when we have these workshop-style events where we're dealing with software or trying to teach people to use computers in a particular way, trying to do data reduction workshop, for example, we can have technical problems. We can have students showing up with a laptop that doesn't actually support the software that they were needing to use. Or we can try and provide a whole bunch of computers in a room, which has a big setup cost of trying to move all the computers into the right space. And these are kind of limitations of the methods that we've been using up until now. So that's my kind of introduction as to why what we have been doing isn't ideal. I'm not going to claim that I have all the solutions, but I have a way to, through the PaN-Training e-learning platform, we have some ways to try and help this. So PaN-Training or the e-learning project is one of the work packages of PANOSK. I'm sure a lot of you are familiar with PANOSK, but for those that aren't, it's really about trying to help the photon and neutron community produce more fair data. At least that's the way I think of it. And included in that is an aspect of user training, trying to create an open platform that we can use for training users, either in production of fair data, but also in our techniques or our software, any of these aspects. I'm not going to say much more about PANOSK because I know that Andy Goetz is in the room because I saw him on the camera earlier. So if you're interested, if you're curious to find out more about PANOSK, just go find Andy and he'll tell you all about it. The PaN learning aspect is actually a sub-project of PANOSK. It's one of the work packages. And the work package is focused on this e-learning platform. Now, the e-learning platform is not the only kind of training aspect of the PANOSK and Expands project. So Expands is a sister project to PANOSK. PANOSK is on the kind of international facility level, and Expands is on the national facility level. Expands has a similar project where they're producing a catalogue of different training that's taken place, either in person or online. Whereas PANOSK is producing this e-learning platform, which, as we'll see, is a platform that we can use to produce e-learning content. And so it means that these two projects end up working synergistically together. So anytime a course is created on PANOSK, it actually goes into the Expands training portal. And so anyone's able to find it using their catalog system. All right, the e-learning platform. So this is the kind of the meat and bones of what I want to talk to you about. Now, what is it? So the e-learning platform is an open platform built on Moodle. If anyone wants to create a course, they can just send us an email, and we're working on making that a bit easier in the future to do. And they can create a course for their neutron or photon linked or neutron or photon linked training event, let's say. So it comes with Moodle's functionality. So not everyone's probably familiar with Moodle. Moodle is an electronic learning platform. It's very popular in universities, so it has a whole bunch of functionality. It has things like interactive quizzes. It has the ability to create wikis or textual documents. You can upload lectures. You can upload PDFs. You can include forums and things like that. It's very common in universities, and as a result, we kind of view it as the best solution that already exists without us having to build our own. So what we've built the e-learning platform on is this Moodle functionality. However, we've taken this functionality beyond just Moodle to include access to a JupyterLab instance that's actually based at the compute resource here at ESS DMSC in Copenhagen. And this means that it can be used in a bunch of different ways to introduce people to programmatic problems or programmatic teaching material. And the thing is, it can then, on top of that, be used in a couple of different ways. We could think of it using it in a massive online course fashion, a MOOC, where we have people log in their own time and just kind of pick at it when they feel like working on it. Things like if you think of things like Coursera, which is a very popular MOOC. This actually helps us because this gets around this selectivity that we create when we organize our workshops traditionally. Or we can use it in a different way if we do organize one of these traditional workshops, because there is still validity to their organization. We can use it to augment the in-person teaching. So I introduced this idea of just talking at people isn't the most effective method of teaching. We should actually try and engage in a more active learning method. The e-learning platform can actually engage with that through things like having material that students are expected to read, quizzes that they're expected to do before they attend an in-person session, such that they can make the most of that in-person session and focus on the kind of meat and bones of what's actually trying to be taught and trying to consolidate the learning that they were expected to achieve. So I'm now going to try and do a demo. We're going to find out how that goes. So this is the e-learning platform. So I went to e-learning.pan-training.eu, and I'm faced with this. So this is the homepage, and the first thing I need to do is I need to log in. So I can do that. I'll just put in my username, my password. And so I've now logged in. One of the things I'm going to do just for the sake of this demonstration is I'm going to change my role, because normally I'm a teacher or a manager, so I'm going to change it to a student. So now I see what students will see when they interact with the e-learning platform. You can see that we've got a whole bunch of courses here. They're categorized in different ways, and people are free to investigate the different courses and enroll themselves in them as they see fit. The examples I'm going to show you are from a recent summer school that we actually organized as a component of the PANAS project. So last week I was actually in Hungary, in southern Hungary, teaching at this summer school that we taught in this kind of flipped active learning approach. And so you can see that this summer school had a couple of different components to it. There was a day focused on X-rays that was organized by the USRF. There's a day focused on lasers that was organized by colleagues from the Eli Alps facility. And there was a day focused on neutrons organized by ESS. There's also this summer school fair session, which is actually really interesting. And I suggest that people go investigate it. It was actually put together by Andy and is quite informative. And finally, there's this lobby, as we called it. So I'm going to open a tab that's the lobby, and I'm also going to open the Neutron Focus Day. So Neutron Focus Day was the day that I put together. I decided to focus it around preparing for a neutron experiment and trying to make sure that you had an expectation of what your analysis and your data would look like before you went to the beam time. And we can add a whole bunch of functionality. So here you can see I have a link to some slides, which the students can go and look through. The slides were actually HTML pages, so they could click on the links that were included in the slides. And then we have some text. So here's some information. The students were invited to read through it, and they had a bunch of tasks that were defined. And as part of this reading, they were introduced to these Jupyter notebooks. So the Jupyter notebooks, there was 2 of them for this first session. There was modeling quants and sharing data. And they were told that they could access these Jupyter notebooks through the lobby, which I actually opened a tab to. So this is a lobby page, and we now have a button called Jupyter Lab. If we click that, this opens something that should be familiar to those of you that have used JupyterHub, where I'm asked to start a server. So what this is doing at the moment is running up some compute resource, actually here in Copenhagen, and we were accessing this from Hungary. So what this will do, this will take a few minutes as it pulls the latest Docker images down. Of course, I should have clicked that before I did the introduction to the other part, but if we just give that a couple of minutes. And the students, oh, sorry, it's made me a teacher again. The students were then able to work through these notebooks that I'll come back to in a second, and they were able to produce a data set. And because we had this, this forum functionality built into the Moodle, we could actually have the students share their data sets on this forum. So for example, here are the students that, some of the students that participated in the workshop in the summer school, and they were able to add a discussion item with a link to their data set that they put up on Zenodo. So I'm just going to find someone that linked with the Zenodo link. So here we are, they created a link where they'd linked to Zenodo, and then their colleagues were able to comment on it and comment on the reproducibility and the fairness as in their opinion of the data set that was produced. So let's see, my JupyterHub is existing. Oh, okay, yeah. So now I have a JupyterHub. You can see that it's loaded the things that I had open previously. I'll just close those up. And it's exactly as you would expect from a JupyterHub. It's based on a Docker image, and the Docker image actually includes functionality for a desktop. So we can launch this Turbo VCN desktop if we want, which launches in a new tab. We have a full, essentially Linux client here. We can also just interact with it as a notebook series. So you can see that I have all these notebooks that I was working with during the lectures. And again, just as you would expect from a notebook, we can create this interactive teaching material. The students can work through it, they can change things, they can break things, and they can try and fix the code. There's additional functionality existing in the Moodle that I'm not necessarily showing here, such as quizzes, but all of this is available. So that was my quick demo, which actually worked shockingly. And the last thing I wanted to say was this has actually been used quite a lot. We've used it a lot in ESS. We're doing training for the instrument scientists in Python. It was part of this PaN summer school that I presented. It's further to that being used by a bunch of outside organizations. So there's some courses that have been produced by ISIS. There's a Swedness course that was produced by a Swedish doctoral training school, essentially. There's courses from TU Delft and Copenhagen University, rather. And further to that, we've actually managed to have an impact kind of outside traditional neutron and X-ray scattering communities that we know of from the PaN community. And we actually got contacted by an academic from the University of Amsterdam who wanted to use the JupyterLab functionality in order to teach this photosynthesis and energy course that they lectured at the University of Amsterdam. And so with that, this is my kind of call to arms. If you're interested in running a course through the PaN-Training e-learning platform, please get in touch. There's an email address here. That email address is also in the abstract if you can't find this talk later on, or you can message me on the Slack. And with that, I'll thank you all for listening. Finished in time. This is a photo of my dogs. The dogs go at the end of all my talks. And if you have any questions, stick them on Slack, and thank you very much.